welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 6, Lesson number 6 on percent increase and decrease. Before we begin, let me remind you that you can find a worksheet and a homework assignment that go along with this video by clicking on the video's description or by visiting our website at www.emathinstruction.com. As well, don't forget about those QR codes at the top of each worksheet. Those allow you with your smartphone or your tablet to scan the code and come right to the video associated with the particular worksheet. Alright, let's begin. In the last lesson, we reviewed how to find percents, and specifically how to find percents by the shortcut method, i.e. multiplying by the decimal equivalent of the percent. Today, we're going to get into situations where we know that something is growing by a certain percent or shrinking by a certain percent. Decaying, declining, decreasing, however you want to put it. So let's start off with some agronomists. Agronomists are studying how quickly the population of an invasive species of beetle will increase in a controlled farm setting. They calculate that the population is increasing at a steady rate of 6% per week. So every week you have 6% more than you had the previous week. At the beginning of the week, the population was 350 beetles. Okay. Letter A. Find the population of beetles a week later by first finding 6% of 350 and adding it to the original population. Why don't you pause the video right now and do that quickly. Alright, let's go through it. Well, finding 6% of 350 as a little review is pretty easy, right? We take the decimal equivalent of 6%, which is 0.06. We multiply it by 350, and we find that that's 21. So our new population will be 350 plus 21, or 371. Now, and this could be maybe the most important part of the lesson, let's take a look at letter B. Letter B says, find the population of beetles a week later by a single multiplication. Why does this work? In other words, I want to figure out that 371, but I don't want to have to multiply, get an answer, and then add. So let's walk through this together. This is very important. What we really did in the problem above is we took our starting population, 350, and we added to it 350 times 0.06. Now this is where it's very helpful to be able to see structure in our expressions, because this is really a binomial, right? It's two terms, 350 and 350 times 0.06. Notice that 350 is a common part of each. So I'm going to actually factor it out. I'm going to factor the 350 out, and then I'm going to go back to blue. And what do I have? Well, I'd have a 1 here, and then I'd have a 0.06 here. So that's going to be 350 times 1.06. Now what I'd like you to do for me right now, and please do this, is pause the video, then take your calculator and do this calculation. Do that calculation. So pause the video now and do that calculation on your calculator. All right. Well, what you should have found was that 371. In other words, if I want to raise or bump up 350 by 6%, then really what I have to do is multiply 350 by 1.06. 1.06. Now, why does this work? Well, this works because we end up with 106% of what we started with, right? We have the 100% that we started with, that 350, plus an extra 6%. And remember, we're always trying to model what remains, and what remains is 106% of what we started with. All right. What's beautiful now is finding the population after 2 weeks is a snap, right? Because we can now take my 371 and just multiply by 1.06 again. And what will we have? Well, we'll actually have a decimal this time, 393.26. And granted, in a certain sense, that's a non-viable solution because we can't have a decimal beetle. I mean, I don't like beetles, but whatever. But we're going to say that that's 393 beetles, right? It's as simple as that. So increasing by a certain percent is very simple. It is an important skill, so we're going to become fluent with it in the next exercise. For now, pause the video, think about what we just did, and take as much time as you need to write things down, and then we're going to clear out the text. Okay, let's do it. It is so important to be fluent with this, but watch how easy it is. Let's increase 440 by 12%. All right. Now we could do it in a two-step process. We could multiply it by 0.12 and then add it on. But to increase by 12%, all we're going to do is multiply by 1.12, right? This is really the idea of having 112% of what remains. Now again, one could think of that as being 1 plus 0.12, right? The 1 indicating the 100%, the 0.12 indicating the 12%. Either way, if we do 440 times 1.12, what we end up getting is 492.8. Don't worry about rounding there, no big deal. All right, why don't you try letter B and letter C? Pause the video now and give them a shot. All right, let's go through them. Well, increasing 68 by 8%, we're just going to do 1 plus that 0.08, 100%, plus another 8%. So in other words, we're going to multiply 68 by 1.08. Please note, if you multiplied by 1.8, you're actually increasing by 80%, which is way more than what we want. Anyway, in that case, we get 73.44. All right, increasing 120 by 3.5%, this might be the hardest one because you've got that 3.5%. Right, what we're really doing is multiplying by 1 plus 0.035, or 120 times 1.035, and that's going to be 124.2. All right, so that's it. 1 plus the decimal version of the percent gives you that multiplying factor. And again, I really want you to understand it. When we're increasing the number, if I said, hey, you know, I'm being paid 10 bucks an hour, but I'm going to get a 5% raise, I'm not going to lose the 10 bucks per hour. I'm getting 100% of that plus an additional 5%. So if I want to know what my salary is, not what the increase was, but my final salary, I take my 10 bucks an hour, I can't even remember what percent I said. Let's say I'm raising it 5%, so I get to multiply by 1.05. Okay? Pause the video now if you need to and copy down whatever you need. Okay, here we go. All right. So let's take a real practical example of this. Adriana has a savings account that promises to increase her balance by 2.5% per year. That used to be a pretty bad percent. It's now actually a pretty good percent. If she deposits $720 in it at the beginning of the year, which of the following would be her balance at the end of the year if she does not withdraw or deposit any additional money? So in other words, we're going to raise that 720 by 2.5%. Why don't you see if you can figure out the final answer by pausing the video now. All right, let's go through it. Well, we could do it in two steps. We could figure out 2.5% of 720 and then add it on. But if we want to do it all in one swoop, right, then what we really want to do is get 100% of the 720 plus an additional 2.5%. So we'll do 720 times 1.025. Obviously, calculators are not nice for this. And we'll find that she has $738. The great thing is if I needed to know how much she had then the following year, I could just take the 738 and multiply it by 1.025. Do that again and again and again. All right, quite simple. I'm going to clear this out, so write down what you need to. All right, it's gone. Let's keep moving on. Now, in the second half of the lesson, what we want to do is start to work with percent decrease. And in a certain sense, that's a little bit trickier. It certainly is trickier for most students. I'm going to try to make you see that it's really the same idea. Okay? So exercise 4. A cup of coffee is cooling down such that its temperature is decreasing at a constant rate of 8% per minute. 8% per minute. Let's say that the coffee starts off at a temperature of 200 degrees Fahrenheit. Find its temperature after 1 minute by finding 8% of 200 and then subtracting. So why don't you go ahead and do that, okay? All right, let's go through the math. So we're going to do this in 2 steps and then figure out how to do it in 1 step. So just like before, 8% of 200, that's simple enough. We're going to do 0.08 times 200. That's going to give me 16 degrees Fahrenheit. That's how much it's decreased. But now we'll do 200 minus 16 to get 184 degrees. All right, so that's simple enough. But again, just like before, we'd like to avoid having to do the double calculation. So let's do exactly what we did before and figure out what one number we can write or what one product we can do to get us that 184. So what did we really do? We took our 200 degrees and we subtracted off 200 times 0.08. Now, just like before, what we really have is this beautiful structure where the 200 shows up in both, right? And what do we get when we factor it out? Well, we get a 1 from here minus 0.08. Makes sense, right? We've got 100% and we're decreasing it by 8%. So we get 200 times 0.92. Right? Now again, pause the video really quickly. Pause the video really quickly. Do that calculation on your calculator and verify that it's 184 degrees. All right, well hopefully you did do that. So you type this into your calculator, you get that 184 in 1 shot, not 2. Now, how can we interpret this? Well, take a look at this number. Think about it in terms of this number or this number, right? The way I interpret this is, after 1 minute, 92% of the temperature remains. All right? So 92% remains, and that's what we're always modeling. How much remains? So what is the remaining temperature? Well, if it went 8% down, then 92% remains. Letter C is easy enough. What will the temperature of the coffee be after 2 minutes? Well, I can take my 184 now and multiply it by 0.92. And that's going to be not so nice, 169.28. But it says round to the nearest degree. Always watch your rounding. 169 degrees Fahrenheit. All right, that's it. Percent decrease is almost always harder than percent increase because it involves subtraction. And for whatever reason, subtraction is harder than addition. It's harder to wrap your hands around it. But we're going to get some more practice with it and be more fluent with it in just a moment, okay? All right, I'm going to clear out the text, so pause the video now if you need to. All right, here it goes. All right, the enrollment of students at a school is decreasing at a constant rate of 5% per year. Well, what percent remains after 1 year? That's easy, right? It's 100% minus 5% gives me 95%. Okay, simple. If the population this year is 2,300, what will its population be next year? Do it in a single calculation. Well, again, this is now where we want to really look at it like this, right? Before we kept doing 1 plus the percent, now we're doing 1 minus the percent. Or we can just think about it as, well, this is the percent that remains, right? So I do 2,300 times 0.95, I get 2,185. All right? So decreasing by a constant percent really boils down to knowing what percent remains. Okay? I'm going to clear out the text, write down what you need to. All right, it's going. So let's get some fluency here. Find the result of each of the following. Many of your answers will involve decimals. Do not round. Write the calculations you use to find your answers. Okay, decrease, decrease, decrease. It's all decreasing right now. Okay, so if I want to decrease 620, decrease by 10%, the way I'm going to keep looking at this, I want this form, right? 1 plus a percent when it's increasing, 1 minus a percent when it's decreasing. So I've got 90% remaining. So 620 times 0.90 gives me 558. All right, decrease, 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 $22.50 by 8%, right? Maybe there's an 8% sale or something like that on an item 2250. Again, the idea is that we're really doing this, 1 minus 0.08, so 2250 times 0.92. Again, I want to just emphasize, if it goes down by 8%, then there's 92% that remains, so that's what we're multiplying by. 2250 times 0.92 gives me 2070. With an artistic box. Okay, decrease 122 by 3.5%. So again, it's all about the decrease here. 122 times 1 minus 0.035. Again, if you get confused by that, what I would suggest doing is taking that and just dividing it by 100. So that's going to be 122 times 0.965. I know this is harder to think about, but when something goes down by 3.5%, 96.5% remains, and that's kind of ugly, 117.73. All right. So make sure you get some fluency with both increasing by a constant percent and decreasing by a constant percent. Pause the video now if you need to, because I'm going to clear out the text. Okay, here it goes. One last problem. What I'd like you to do is read this over carefully and try to get the correct answer. All right, pause the video now. All right, the cost of gasoline has decreased. Important to know whether we're increasing or decreasing. Has decreased recently by 4.5%. I was going to almost say 45%, which would be awesome. If it started at $3.80 per gallon, which of the following is its price after the decrease? All right, so this is one like what we just worked on. If I take my 380 and I do 1 minus 0.045, right? Well, that's going to give me 0.955. In other words, a 4.5% decrease leaves 95.5% remaining. Okay, and that's why that number's right there. But then when I multiply those two together, we get 3.629. Okay, don't confuse this with a viable versus non-viable solution. It just means the gas is $3.63 a gallon. That's all. All right. So Pause the video now, write down what you need to, and then we're going to finish up the lesson. Okay, all clear. So in this lesson, we used our shortcut for finding percents to find an additional shortcut, actually two shortcuts I suppose, to increase a number by a certain percent or decrease a number by a certain percent. These will help us build more complicated and more realistic exponential functions / models in coming lessons. For now though, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kurt Weiler, and until next time, keep thinking and keep solving problems.